Let's explore database sharding strategies. We'll focus on scaling database architecture through horizontal partitioning. Some of the popular strategies are range-based, hash-based, and directory-based sharding. Database sharding is a horizontal partitioning technique. It involves splitting large databases into smaller, more manageable pieces. These smaller pieces are called shards. Think of it as dividing one big database into several smaller databases to improve performance and manageability. Range-based sharding involves distributing data based on value ranges of a specific key. For example, the data can be partitioned alphabetically. Records with keys starting with A through F might go to shard 1, G through M to shard 2, N through S to shard 3, and T through Z to shard 4. This method is simple to implement when the range of values are easily determined. Here's an example of how to implement range-based sharding using a function. The function, named getShardByRange, takes a user ID as input. If the user ID is less than or equal to 1000, it returns shard1. If the user ID is less than or equal to 2000, it returns shard2. If the user ID is less than or equal to 3000, it returns shard3. Otherwise, for user IDs greater than 3000, it returns shard4. Hash-based sharding uses a hash function to determine shard placement. The formula is hash of key modulus n, where n is the number of shards. The result of this operation is the shard ID where the data will be stored. This ensures a uniform distribution of data across all shards. Here's how to implement hash-based sharding. First, import the hash library. Next, define a function called getShardByHash, which accepts a user ID and the number of shards as inputs. The hash value is calculated using the hash function on the user ID. The shard ID is then determined by taking the hash value, modulus the number of shards. Finally, it returns the shard ID as a string. For example, calling this function with a user ID of 12,345 and 4 shards will determine the appropriate shard for that user. Directory-based sharding uses a lookup service to map keys to specific shards. A directory service maintains the mapping between keys and their corresponding shards. When a request comes in, the directory service is consulted to determine which shard holds the data. Requests are routed to the appropriate shard. This method offers flexibility in data placement. Let's compare the sharding strategies. Range-based sharding supports range queries and has simple logic, but may suffer from hotspots and uneven distribution. Hash-based sharding ensures even distribution and avoids hotspots, but does not support range queries and has resharding complexity. Directory-based sharding offers flexible mapping and dynamic allocation, but introduces lookup overhead and a single point of failure. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.